Okay, so let's go through how to answer exam questions properly. So this is the 2021 Edexcel paper, and remember, it's all about the exam technique. That's what's going to get you the good marks here. So when we're doing all the questions and when you're doing your practice papers, you always just need to make sure that it's the exam technique that you're applying. So for question number one, the first thing that I've always got to do is I've got to make sure that I've identified the main topic of the question. So obviously here I can see, yeah, it tells me very easily that it's about ultrasound. So as soon as I know it's for ultrasound, obviously I've got to make sure that I know my content, I've remembered my content, and I know that all the questions on ultrasound are going to be testing me about something about the range of human hearing. So I know I'm going to get something that's about the range of human hearing is 20 hertz to 20 kilohertz. That ultrasound is above 20 kilohertz. That's the kind of stuff that I've got to try to remember. And all the questions, I know I'm looking out for the question to be testing me on that. So I'm looking for question number one versus, which is ultrasound, which is the frequency of ultrasound. So straight away, I know I'm just looking for a number that's above 20 kilohertz. So then obviously all of these numbers are below 20 kilohertz apart from this one. So I just know straight away, oh yeah, the answer's got to be D. So that one's pretty simple. Okay, and then the next one, okay, still following the ultrasound theme, and I'm looking for what's the important piece of information they're giving me in this question. So it tells me, okay, it emits ultrasound, it keeps mice out of the garden, explain why it affects mice but doesn't affect humans. So straight away I know that, okay, it's saying it doesn't affect humans. So I'm thinking, okay, what keywords am I going to use here? What's the content that the examiner wants me to say in this answer? And the fact that it's telling me that it doesn't affect humans, well, straight away I know, oh, from the thing that I predicted earlier, I know that human hearing range is only between 20 hertz and 20 kilohertz. So if it doesn't affect humans, I know that it can't be in that range. If it says ultrasound, well, it must be above 20,000 hertz. So firstly, I'm just showing the examiner I know what the definition of ultrasound is. So I'm just going to write the frequency must be above 20,000 hertz or 20 kilohertz. And then I've just got to make sure that I'm linking that to the question. And saying, well, why don't it affect humans? I'm going to say, well, it's outside of the range of human hearing. I'm just making it very explicit that I'm just saying exactly what the examiner wants me to say. Outside of human hearing range, but inside range of hearing for mice. So the reason or the way that I've got this right is because I've said the keyword in there. I know what the examiner wants me to say. I'm giving a key piece of information that I have got from the content, and then I'm just making sure that I'm very explicitly applying it to the question, and therefore I'm going to get the right answer. Okay, so for the next part of the question, again, I've got to identify what type of question it is first. So I'm looking at what it says, obviously read the question properly, and I'm seeing the main thing here. It says, describe how the technician can use the device to determine the speed of ultrasound. So the fact that's got this word determine here, I'm going, okay, it looks like this is an experiment question now. So because when it says investigate or determine or practical or anything like that, I know, okay, there's the same method that I know that I'm going to get the marks for. So the first thing that I've got to make sure that I'm doing is saying the formula for the thing. So I've got to try to identify some kind of formula if I can. And what's the formula here? Well, it says I'm trying to determine the speed, so obviously it's got to be a formula with speed in there. And then what am I trying to do? So it says, oh, it measures the time as well. So the fact that it says the speed and time, this is telling me that the formula is obviously going to be speed equals distance over time. So I'm just going to write that down first and just get that mark in the bag, and then I can worry about all the other stuff afterwards. Okay, so after I've got the formula, I know that I'm going to get marks in the practical questions for something saying about the equipment that I'm using to measure. So I've got to say I've got to use this equipment, measure this equipment, measure that. So speed is sorted because that's what I'm looking for, so that's fine. So what's the next thing in the formula? Distance. What am I going to use to measure the distance? Obviously meter ruler. So I'm going to say meter ruler to measure the distance. And then time, obviously I've got to try to measure that. Well, it tells me in there that the device measures the time as well. So I might not need to say it, but I might as well just play it safe and just say it anyway. That's changed my R to M. So the device measures the time. So I'm not sure if that, when I'm sitting the exam, I'm not sure that this is going to get me a mark because it tells me that in the question. But I might as well just, I'm not going to lose anything by saying it. I might as well just play it safe and say it. The next thing that I'm doing after that is the method or some kind of detail from there. So now I've got to say exactly what I'm doing. So I know that it says the device emits and detects short pulse of ultrasound. So I'm just going to say, oh, something like point the device at a wall, emit a pulse, something like that. So send pulse to wall, and then determine time for, and I'm trying to get a keyword in there, so pulse to reflect off wall and come back. Now I've realised the thing that a lot of students will get tricked on or forget to say for these questions, and it's something that they're always testing on there. I've remembered when I'm doing an ultrasound question, it's coming there and back. So if I'm measuring the distance to the wall, I've got to say it's 2 times the distance from there to the wall. So measure distance to wall and multiply by 2. And then I'm just going to say, put that in the formula, obviously, because I've said that. So I'm going to say that the speed will be the 2 times distance divided by the time. And then I'm always just going to say repeat and take an average. For any experiment questions, I'll just draw a line there to make sure. So I'll say repeat and take an average. Now, I don't know which ones of these are going to get me the mark in this particular question, but if I'm saying all of these things for every experiment question, then at least I know, okay, I'm definitely going to get full marks. So I'm sitting there, I'm confident that I've at least, I've said at least 3 or 4 things here. I'm definitely going to get the full marks for that question. Okay, so looking at the next question, I'm seeing that, okay, there's a question about waves. So I know that they're going to be testing me on something about, do I know the definition of frequency, amplitude, wavelength, all of that kind of stuff is what I'm going to be looking out for. And I can see that it's a graph question as well. So I know that I'm going to have to take readings from the graph. I'm going to have to draw on the graph at some point to show that I know I take readings from there. So now I'm ready for all that stuff. Let's take a look at the question. So it's saying use data from figure 1 to calculate the wavelength of the wave. So that's the key thing that they're looking for. Now, because I'm using the data from the graph, basically I need to know what a full wave looks like. So if it's saying wavelength, I need to know that wavelength of one wave looks like this. So if I compare that to the graph they've been given, what if I look at this point over here, they've only given me half a wave. So I know that one full wavelength, if I get that multiplied by 2, okay, that's what's going to be the wavelength. So the first thing that I'm going to do is show the examiner very clearly that I have got that point from the graph. So I'm going to make a mark on there like I've already made on there, and I'm going to show the examiner that I know that this is 14 centimeters at this point. I've made that mark on there. So I'm going to now make clear why I've done that. I'm going to say half a wavelength is equal to 14 centimeters. Therefore, wavelength must be equal to 28 centimeters. Because I'm very, very clearly showing exactly my working. So if I read something wrong or something like that, well, at least I've got my working in there. So I'm showing the examiner exactly what I've done. So 28 centimeters, and I'm just checking the unit. It says centimeters, so that's fine. I don't need to do any conversions there. Okay, so this next question, so I'm reading what it says, and again it says, how can I determine the frequency? So that word determine again is telling me that this is a practical question. It's going to be something to do with the practical. So what am I trying to determine the frequency? Well, obviously I need some kind of formula that's got a frequency in there. So there's a couple that I could use here. I could use V equals F times lambda, that's got frequency in there as well. Or I could say frequency equals 1 over time period. And I've got to say for this situation, which of them looks like it's the most reasonable? Well, if I'm looking for determine the frequency of them, looking at toy boat, it's probably bobbing up and down. It looks like this bottom one is probably easier for me to do. So that's the one that I'm going to try to do. So the first thing that I'm going to do, as always with any practical question, is I'm going to say frequency is equal to 1 over time period. I'm going to give the formula. So frequency equals 1 over time period. Now I've got to have a look at the equipment still. So frequency is what I'm looking for that sorted. 1 is 1, that's sorted. How am I going to get the time period? So I know that I'm going to probably use a stop clock to do that. So stop clock to measure time period. Now the next thing is always a method, something sensible, some kind of detail. So what's the sensible thing that I'm going to be saying here? Well, I'm not just going to measure it once. The detail that I'm going to add in there is I'm probably going to measure like 10 time periods or something like that. So I'm showing the examiner that I know. I'm going to count the time period for 10 waves or something like that. So I'm going to say time 10 waves and divide by 10 to get one time period. And then after I've done that, I know that I can put that in the formula, so get frequency with f equals 1 over t. And then I'm always going to say repeat and take an average. I won't write out in full, but in the exam, obviously, you have to write out in full. So I'm just going to say repeat and take an average for every single practical question that I've got, just to play it safe. Sometimes what might come up with this question is if it says something like about accurately or other piece of equipment that I can use, if I'm seeing that word in there, then I'm also going to mention about like using a phone or some kind of like video recorder or something like that, that I can record the waves and then slow it down afterwards. So I'm looking for the word accuracy in that kind of question to get that mark there. Okay, the next one that we've got over here is, I'm pretty happy with this, it's a normal formula question, and they've been so nice that they've given me the formula as well. So the first thing I'm going to do, check for conversions. Are there any conversions here? So meters per second is sorted, hertz is sorted as well. I don't need to do any conversions. Well, they've given me the formula, so I don't even need to identify it, but I'm still going to make sure that I'm consistent and I'm writing it down exactly. Okay, what am I looking for here? I'm looking for the wavelength. So that means that wavelength is the one that I'm going to write first underneath where the wavelength is. Now I can fill in the rest of the numbers. So have I got a V? Yeah, I have. It's 1.5. Have I got F? Yeah, I have. It's 0.7. So I'm putting the numbers in this order because now at least I've got my substitution mark, that if I mess anything up afterwards, it's very clear to the examiner that I know that this is V and I know that that is F, so I'm getting that mark. Okay, now I need to rearrange it. So I'm going to say therefore the wavelength equals 1.5 divided by 0.7. Again, I'm making sure that I'm showing my work in. I'm going to put that in the calculator, and I'm going to always write the full number of my calculator. So it's like 2.14 something something something. I'm going to write the full number of my calculator, and then even though it doesn't say it here, I'm going to make sure that I'm rounding two significant figures on my answer line, just to get in a good habit of doing that. So I know that that wavelength is going to be 2.1 meters. Okay, and then the next one and last one for the waves question, what's the key piece of information they're given here? Okay, transverse, and telling me about transverse and longitudinal. Now with any question where it says give the difference between something and something, I know that if I just define those two things, that's going to help me out with that. So I can just define them separately, and I know I'm going to be getting the marks from there. So what's a transverse wave? Well, I've just got to make sure I remember the keywords. So the transverse wave is a wave where the oscillations or the vibrations, whoops, I should have said transverse here. So for transverse, oscillations are perpendicular to the direction of the energy of the wave. And then, therefore, for longitudinal, I've got to make sure that I'm saying that as well. So for longitudinal, the oscillations, I was going to say are. And I know that the keyword for this one is going to be parallel, and I'm going to say the same thing, and I'm making sure I'm saying to the direction of the energy of the wave. Just to play it safe, because sometimes I'll accept direction, sometimes I'll accept energy. I just want to make sure that I'm getting the marks, so I'm just going to say both of them properly. So the next question that I've identified is about radioactivity. So again, I need to just make sure that I know my content for all of them is something alpha, beta, gamma, and then which statement describes all of them. So I'm just having a look at the options that I'm given, and I can see from here that the two things are either ionizing or neutral, and then it says stable or unstable. So I've got to decide, okay, is radioactivity ionizing or is it neutral? Is it from stable or unstable? And I know that it's got to be ionizing, it's got to be from unstable, and all the others different variations of that apart from B. So I know that B is the correct answer. So I'm happy with that one. Next one, okay, what's the keyword that stands out to me in this question? What's the thing that the examiner is trying to test me on? Well, the keyword that stands out here is isotope. Now I've just got to remember what is meant by isotope. So I'm already thinking, yeah, I know what isotope is. I know that it's something that's got the same number of protons and a different number of neutrons. So now I'm just reading the question, what's one similarity and one difference between a nucleus of fluorine 19 and an isotope? Well, I know the only thing that they're going to test me on an isotope is that the similarity is the same number of protons and different number of neutrons. So when I see the word isotope in there, in any question where it mentions isotope, I know that this is the thing that I care about, this is the thing that they're testing me on. Okay, so again, reading this question, so you've had a go at this one, you start by now, hopefully. So reset to 0, explain why the new count is greater than 268. Well, what is it mentioned here? It's mentioned the fact that it's a beta radiation. So that's the thing that stands out to me. And it says that there's an aluminium sheet there. So I'm suspicious about the fact that it's beta, I'm suspicious about the fact it's an aluminium sheet. And then it says the aluminium sheet is taken away. So what is the key thing that the examiner is trying to make me realise here? Well, I know that beta is absorbed by aluminium. So I'm just going to make sure that I'm showing the examiner that I know the content. So I'm going to say beta is absorbed by aluminium. And then because I've got to try to link it to the question, I'm going to say, well, if the aluminium sheet is taken away, obviously the beta is not going to get absorbed. So there's no sheet to absorb beta, therefore count will be higher. So as always with the exam technique, I'm making sure that I'm showing the examiner the key thing, the key piece of information that they want to get from that topic. I'm just saying that straight away to get a mark for it, and then I've linked it to the question afterwards. Okay, I'm going to get the mark for that. So the next part of this question is saying the beta source is taken away. There's still a count on there. Now I'm always looking, this is always going to be like a 1 or a 2 mark question on the exam. What's the reason for it being when there's not a source there? Why is the counter still going? And I know the answer is going to be background radiation. So I'm waiting for this to get my 3 mark for all radioactivity questions. Background radiation. Now if this was a 2 mark question, sometimes I might give it a 2 mark question, you have to give a source as well. And I just need to know from my revision guide, what are the sources from there, and I can just give one of them. So coming from e.g. rocks, or just something that's on your revision guide, whatever you want to say. Even though it's a 1 mark question, I might as well still say it anyway, because I'm not going to lose anything by being safe and just giving extra, show the examiner that I know the extra piece of information I've been revising. SI unit for the activity of a radioactive source. Again, I should just know what my unit of all the basic content I should just know. So I'm going to write down becquerels for that. And then the next question up here, okay, it's a calculation question. So I know there's going to be some kind of mass involved here. And because it's half-life, I'm always answering every single half-life question the same way. So what I'm looking for is some kind of initial activity or mass or number of nuclei. I know what the half-life is going to be, and I know that the time that they're going to give me is some kind of multiple of the half-lives. And then, yeah, I'm just seeing what I'm doing with that. So I'm going to start off by writing down what the initial, whatever it was. And in this case, it's nuclei. So I'm going to start off by writing that number 1.7 times 10 to the 23. And then I know the half-life that they've given me on my answer is always going to be a multiple of the half-lives. So the time period they've given me is going to be a multiple of the half-lives. So here it says 33 days. Well, obviously I know that's 3 half-lives. Now I can write that separately, because if I do something wrong with my calculation, I can get a mark for just showing the examiner that I know that this was 3 half-lives. So I'm just going to do that separately. And now if I do type something wrong or anything like that, well, it doesn't really matter, because, well, I mean, I haven't lost all of the marks for it. At least I've got that thing there that I've shown the examiner that I know that thing is true. Okay, so I've just got to do it the proper way now. So I'll have a look after 1 half-life. I know it's going to half, so that's 11 days there. So after 11 days, I've just got to divide this by 2. So I'll put that in my calculator, and I know that's going to be 8.5 times 10 to the 22. After another 11 days, it's going to half again. So that is now going to go down to 4.25 times 10 to the 22. After another 11 days, it's going to half again. I've just got half that again, and now that's gone to 2.125 times 10 to the 22. Now I've done my 3 half-lives, so I'm happy that my answer has got to be this, what I've just written down from a calculator. But like we're saying for all the maths questions, even though it doesn't say round to 2 significant figures, I should just get into the habit of rounding to 2 significant figures. So 2.1 times 10 to the 22. And I'm pretty happy that, yeah, this is going to be the right answer now. Okay, so this next question then, the astrophysics topic. So it's asking me about the Big Bang. Now I know when they're asking me about this, there's 2 main things that I need to make sure that I'm knowing about redshift and CMBR, and I need to know the different things that they're showing me. So what's redshift evidence for? What's CMBR evidence for? And I know that that's what's going to be tested in this question, whether it's 3 marks, 6 mark, 4 mark, whatever it is. Okay, so which of these proves that the universe had a beginning? So I know that it's not going to be A, B, or C, it's going to be D, the discovery of cosmic microwave background radiation. So this is the thing that proved that the universe had a beginning. And then redshift proves that the universe is expanding. So sometimes, and what they're more likely to do in the real exam is have one of those options about redshift, because that's the one that students get mixed up about. In this one, there's not really anything you can get mixed up with, but in the real one, yeah, students get mixed up that, is it redshift that proves it's got a beginning? Nah. Is redshift that proves that the whole universe is expanding, and it's CMBR that proves that the universe had a beginning. So evidence that, for part B, evidence that the universe is still expanding because of observation of light from distant galaxies. Okay, so now, basically, yeah, this is my opportunity that I've been waiting for to say something about redshift. So it's how does light from different galaxies show the universe is still expanding? I've identified this as a redshift question. So straight away, I'm just going to use the key term in there, redshift. Hopefully, again, by using the key term, this is hopefully going to be a separate marking point, and I'm going to get the mark for that. Now, obviously, that's not going to be good enough because I need to show the examiner that I know what is meant by redshift. So what's meant by redshift is when the observed wavelength or the perceived wavelength, and at GCSE you can probably just get away with saying wavelength, but again, might as well just be safe and say the observed wavelength or the perceived wavelength is increasing. Or you could say the wavelength appears to increase or something like that. But it's got to be the key term that you're using, the wavelength here. I've used the symbol, but obviously you should be writing the full word. Okay, and then yeah, I'm happy that I've got 2 marks on that. Okay, so for part C to this question, steady state theory is also a theory about the origin of the universe, 1 similarity and 1 difference. So again, I just got to make sure that I know these 2 theories. And the similarity between both of them is they both think that the universe is expanding, but only Big Bang theory says that the universe had a beginning. And obviously when I'm abbreviating the stuff here, you got in the real exam, use the full terms. Okay, so next question, the first thing that I've spotted here is that there's some kind of graph from there. So I've got to use the same thing from the graph questions, that I'm always looking that I'm going to be taking some kind of reading from the graph at some point, and I've got to mark that on there to show the examiner that I know what I'm doing. And then it's come up in the very first part of it. So estimate the velocity of a galaxy that's 15 megaparsecs away from the Earth. Now, I've always got to make sure I'm drawing on the graph here. So in the real exam, obviously, you're going to be using a ruler. But you've got to draw a line from there, the 15 up to the line of best fit, and then go from there across. You'd be using a ruler. I'm not here, but okay. And then that's where the thing gets to. Now I've just got to be very careful with the scale from that. I can maybe just zoom in to have a look properly, because I got to know what it's going up in. I can't just say, oh, it's going to go up in 1s or 2s. That's where students will make a mistake quite often. So if this one here is 1,500 and this one here is 1,000, I know that each 2 squares must be 100. So that is 1,100, 1,200, 1,300, 1,400, 1,500, so I'm happy that that's the scale. Well, if it's coming here, I know that must be 1050 because it's in between 1,000 and 1,100. So I'm just going to put 1050 in there, and then that's going to be my answer. Okay, calculate the gradient of the line that's shown in figure 4. So whenever I'm trying to do a gradient, I'm always trying to take the biggest triangle possible. Now I don't know here that it's going through 0, 0 because the line hasn't gone in. I might want to extrapolate and show that it is going through 0, 0, and then that can be a point from there, and then I can take any of these points from here, or I might just want to choose any 2 other reasonable points from there. And when with a ruler, you'd be showing that again, that you've got that big triangle, just read what those points are on there. But always, as long as you're showing your work in, you know that you're going to be getting the right answer from here. So I've got to just show what those points are. So the gradient is always going to be the change in y over change in x. So I'm going to show the examiner that I know what is meant by the gradient is changing y over changing x. Okay, change in y. So this is the y-axis over here. Now again, I can say which numbers that I'm going to be using as long as I'm showing it on there. So for the purpose of this question, I might just use this point over here, the one that I've already got the numbers for, and then I'll use 0, 0 because I extrapolated. But again, it doesn't really matter which ones you're using. You might want to use this one and this one, or whatever it is. That's up to you. So the change in y, I know it went from 1050 to 0, take that away, and then x is from 15 to 0, so I'm going to say 15 to 0. Now I'm going to put that in my calculator, so that's going to be 1050 divided by 15, and then the answer for that is going to be 70. So I'm going to write, and that's the full answer that's come from my calculator, so that's fine, so I can write 70 in there. Now when I'm getting a unit, well, what have I just done? I've divided by y by x, so this y over here was in kilometers per second, so I'm going to say the kilometers per second, and then divided by megaparsecs. So I've got to make sure that I'm saying divided by megaparsecs. And again, I don't really need to know anything about what those things mean. It doesn't matter because I'm just showing the examiner I know. It must be whatever the units must be, because I divided that by that, it must be the units. So I'm just going to write that here. So kilometers per second per megaparsec, and I don't even need to make it more complicated than that. That's fine. I'm going to get the answer for that, or I can write it like this if I want to make it look a little bit nicer. That would be okay. You might want to say kilometers s to the minus 1, megaparsec to the minus 1. Both of those would be perfectly fine as well. Okay, the gradient of the line can be used to estimate the age of the universe. Why is it only an estimate of the age of the universe? Well, I've got to have a look at the graph for this to see why that's the case. And I can see from there, if I'm looking at the graph, all these points are all over the place. So this is just a line of best fit. So that gradient, it's not the neatest points I've ever seen in my life. So it's probably going to be something to do with that. So I'm just going to show the examiner, because it says about the gradient of the line, I'm just showing the examiner that I know something about the graph. I'm just going to refer back to the graph. So the points are scattered quite a lot, and therefore there's a wide range of possible gradients. Now, because this is for astrophysics in this context, but a graph question could come up, an unfamiliar graph, in any different topic. So it's just important that you know generally what you should be doing for the unfamiliar graph questions. Okay, so next question. I can see again there's a graph in here, so I'm looking, okay, I'm probably going to take readings from the graph, something like that. So first part of the question is telling me, okay, draw the best fit curve. Now this has been quite nice because it's telling me it's a curve in there. It's not even making me judge it for myself. But I know that in the real exam, if I'm having to draw a line of best fit, it's either got to be a straight line with a ruler, or it's got to be a smooth curve. They're the only two options. I say it can never be a dot to dot. It doesn't have to go through all the points, but in this one, it kind of looks like because all these points are quite nice, so it probably is going to go through all of them. So I'm just going to try and do a smooth curve. I'm not going to do a dot to dot. That's going to go through all the points, and then I'm sorted there. I'm pretty happy with that. I'm pretty confident I'm going to get that mark. Okay, the next question. So this is the one that I was kind of looking for. I know that when I see a graph, I'm always going to take readings from there. Now this is slightly different to other ones because it says when angle is 80. So 80 isn't within the points I've got, so I know I'm going to have to extrapolate. So if this was my smooth curve first, I'm just going to have to carry on with that curve in a reasonable manner, so it kind of looks like, yeah, maybe it was going in this way over here. So I've extrapolated that, extrapolated my curve, and now I'm gonna still show the examiner I've got to go up from 80. So I'm going to use a ruler in the real exam and put that here, and then again take this reading over here, and still I've got to be careful with my scale. So in this one, this is where my lines hit it. This is 40, this is 45. So I know, okay, this one, 41, 42, 43, 44, 45. So I'm happy that's going up in ones. So my answer that I'm going to say here, yeah, from my curve that I've drawn, is going to be 41. Now, obviously, because you're extrapolating, there's going to be some variations in what you might say. So it's even more important that you're showing work. You should obviously always show your working anyway, but it's even more important that you're doing it, because then even if you get something slightly wrong and you've done a slightly different curve, you can still get a mark for it because I've shown my working very, very clearly. Okay, so the next question, so it's a graph question, and it says describe in there. So I'm always going to say the same thing when it's described for a graph question. It's always got to be, as the something increases, the something either increases or decreases or stay the same. So I've got the two things in there, and then the first thing that I can see is that as I increases, R also increases. So I'm just going to say as I increases, R increases. Now the next thing that I've got to say is it directly proportional or is it non-linear? Well, I can see from there it's not a straight line through the origin, and it's a curve, so I know it's going to be non-linear. And then this is a 2-mark question, so I'm pretty happy that I've got 2 marks from there. But just in case I'm not getting the marks for this part, the other thing that I should always be doing with graph questions is make sure that I'm giving numbers. So I'll say, for example, when I was 10, R was 8. So that's 1 point that I've taken over here. When I was, and then I just give any of them, so I've got to take 2 points when I'm giving numbers. I was 50, R was 31. And now I'm happy that I'm going to get all the marks for this question. Next part for this one, again, this is just something that I've got to know. So it's saying that when the what's going to happen to the wave velocity and the wavelength when the light travels from air to glass. So what's the formula that links those two things together? I know that velocity is going to be equal to frequency times wavelength. So I can see from there what's going to happen. I know that frequency always got to stay the same. It tells me that in the question anyway, but I shouldn't, like, that's just something I'm expected to know. So even if it didn't tell me in the real exam, I've just got to know that frequency, whatever a wave goes, the frequency is always the same. And then I know that because it's light, I've got to know what happens to light when it goes from more dense to less dense, or less dense to more dense. So in this case, it's going from air to glass. So I know it's going from something that's less dense to something that's more dense. Well, I know that therefore the velocity is going to slow down because it's light. When it goes into more dense, it slows down. If it's sound, it's the other way around. So that's something they might try to trick you on. Well, I know if V is going to decrease because F stays the same, I've got to know the relationship, the proportionality relationship. So I know that wavelength is also going to go down. Therefore, I'm looking for one that says they're both going to decrease. Well, the only answer that says they're both going to decrease is A. So I'm pretty happy that that's going to be the right answer here. Okay, and then now the next question, only the refraction is shown. Other things happen to the light when it goes from P to Q. So explain the decrease in intensity as the light travels from P to Q. Well, it's already given me a pretty big clue here that other things are going to happen when the light travels from P to Q, and it's only refraction shown. So I know, okay, something else must be happening that isn't refraction. So what else is a phenomenon of waves that I need to know? Well, when a wave's hitting a boundary, some of it's going to refract, some of it's going to reflect. So I say that some light is reflected. So I've just used the clue that they've given me in the question to make sure that I'm getting that first mark in there. The fact that it said other things, or what's it going to be? Okay, where's it going to be reflected? Well, it's always reflected at the boundary. So I've just got to say reflected at the boundary or at the top edge or something like that. So that might be my second mark. A boundary or top edge. Either of those, I'm pretty happy with that. And then what else is going to happen? So when the light is traveling through the glass, I know that light is going to be absorbed as well. And just like I gave the position of where it's going to be reflected, I have to say where it's going to be absorbed as well. So it's going to be absorbed by the glass. Now I've said 4 things here. So even if this was a 4-mark question, I've probably got the 4 marks for it. But okay, it's a 3-mark question. And so I'm just playing, so even if I got something slightly wrong, well, at least I've said all the things that I know about that, and I know I'm going to get the full marks for that. Okay, which of these sketch graphs represent the speed of light as it travels from P to Q? So I've got to be pretty careful here. Now, the way that I should always do these kind of questions is don't look at the graphs and go, oh, this one looks nice. I've just got to think, okay, what do I actually know about this situation? So what do I know about the situation when it goes from P to Q? Well, when it's in P, it's in air. Then it goes to the glass block, and so it's obviously in glass. Then it goes to Q and it's in air again. So I know the speed of light is going to be consistent when it's in P. So if I've got a speed against time graph, I think that's what they all are, or speed against position, I know that the speed is going to be constant first. When it goes into the glass, it's going to immediately drop down to whatever the speed of light is in glass. So it's just going to drop down to this. I know it's going to be less, so it's got to go down. So in the glass, it's going to be something like that. And then Q's over here, so it got to come out of the glass again, and then it goes back to the speed in air. So I'm looking for a graph that looks kind of like this. So I'm going to look at all the options and hope that there's a graph that looks like this. And yeah, there is. So this one is showing me that it was 3 times 10 to the 8 to begin with. It was 3 times 10 to the 8 at the end. And then at some point when it was in the glass, it was less than 3 times 10 to the 8. So the answer for this one must be B. So I'm going to mark that one. And again, I'm pretty happy that that's bound to be the right answer. Okay, so this next question, let's have a look at the key things that stands out to me in the question. Well, obviously it's graphs, and they're saying displacement time graphs or velocity time graphs. So this is a popular trick that they put in there because they know students get mixed up. Well, they're giving me the key piece of information that's a constant velocity, and they've also given me the key piece of information that is 2 meters per second. So the first thing, because I already know I'm prepared for these tricks that are coming, I know that for constant velocity, if it's a displacement time graph, this is showing constant velocity. If it's a velocity time graph, this is showing constant velocity. So these ones, so B and D, are my velocity time graphs. Well, if it's constant velocity, it would have to be a line like that. So I'm just ruling these out straight away. They can't be the answer. So it must be either A or C. So now what's the next piece of information? It says 2 meters per second. So there's a couple of ways I can do it. I can either realize that velocity is displacement over time. So I've just got to get the displacement and get the time off each of these graphs to see what it is. Or I can remember, which is the same thing, that if I get a displacement time graph, the velocity is the gradient, because velocity is going to be y over x, which is displacement over time. So let's do it with this graph and see what I get. So at a time of 4 seconds, I have got a displacement of 8. So I'll just put that into the formula. 8 divided by 4 is going to be equal to 2. So I'm pretty happy that, yeah, the answer is probably C, but I've just got to double check to make sure that I haven't done anything wrong. So for this one over here, the displacement is 2 when the time is 5. 2 divided by 5, well, I know that's not equal to 2. So therefore, obviously the correct answer is C. And I know that I will have got that one right because I've already identified what the tricks might be, and I'm ready for them. That I know that I'm just not going to fall for it. Okay, so now for this one, we've got a calculation question. So that's going to be a formula, and then it actually tells me calculate the acceleration. So these ones are a little bit easier maybe, because when it says calculate the acceleration, I know that it's either going to be this formula or it's going to be this formula. And what's the difference between these two formulae? What's the thing that I'm looking out for? Well, the top formula's got a t in there, the bottom formula got an x in there. That's the only difference between them. So when I'm in the exam and it says calculate the acceleration, I know I'm looking for either a t or I'm looking for an x or a distance. Well, what does this one give me? It gives me a t. So because it's giving me the time there, well, I know it's got to be that top formula. So that's sorted. So a equals v minus u over t. And I'm just going to make sure that just like I should be doing for all graph questions, I'm drawing on the graph so the examiner can see exactly what I'm doing here. So it says after 34 seconds, so I've got to go to 34 seconds, draw a line up there with a ruler, draw a line across here with a ruler, obviously you're going to be using a ruler, and then I can see that that value there is going to be 26, just like we've seen in one of the previous questions. Just be careful with the scale. I can see that this is going up in ones, so I'm happy. Okay, so now I'm just going to put this into the formula. Well, what am I looking for? I'm looking for the acceleration. So I've checked the units already, so meters per second and seconds is fine. Even if it's a graph, I should still be checking the units on a graph. So having been given A is what I'm looking for, so I'll write down A first. V here, it says it's the final velocity after 34 seconds is 26, so I'm going to write down 26. Have I got an initial velocity? Yeah, I have, because when the time was 0, the initial velocity was actually 14, so some students will just put 0 or miss it out or something like that. I've got to be very careful, and by using the formula, I can't really make a mistake here. So U is going to be 14, so I've put that in here, divided by 34, because it tells me the time is 34. I'm going to put this in my calculator. I'm going to, as always, I'll write the full number for my calculator, so 0.3529, blah, blah, blah. And now I'm going to round it, because I've got into the habit of rounding everything to significant figures. So on there, I'm going to put 0.35. Now in this question, actually look, it does tell me give your answer appropriate no significant figures, but I might miss that, because by the time I'm doing all this stuff with the graphs and all the lines and everything like that, I'm just so happy I finally got an answer. I'm just going to go, oh yeah, good, I'll move on to the next question, and I won't see this. But because I'm used to rounding anyway, I always round two significant figures, the fact that it says that, well, good, now I've got them, otherwise I would have lost that mark for absolutely no reason. Okay, so the next question, calculate the distance that the train travels. So I already know that this thing is accelerating. So what some students might do here is they go, oh yeah, distance, I know formula for distance, our speed equals distance over time. Well, I can't use this one because it tells me the thing is accelerating. So just like we said for the previous question, if it's accelerating, I've got to use either this formula over here, or I've got to use this formula over here. And the only thing I'm looking at is, does it give a time or a distance? Well, this time it gives a distance, so that's an obvious indication I've got to use the bottom one. So as always, I'm going to make sure that I'm writing down the formula. What am I looking for in this situation? I'm looking for x. So it's x that I'm going to write down first to make sure I don't mess anything up. I'll put equals under the equals, and now I can fill everything else in. Have I got v? Yeah, I have. So my v is 26. I already looked at that before. So 26 squared, because it says squared there, I'm not going to forget the squared. A u is 14, so I've got to put 14 squared. Again, I'm not going to forget the squared. 2 is 2. Now for the acceleration, I'm putting times there. Some students will just go, oh, acceleration is 10, it's always 10. But obviously I've just worked out the acceleration here. It's only 10 when something's dropping. This ain't dropping, so the acceleration is not 10. So I'm going to put actual acceleration of 0.35. Now, if I'm confident, I can just rearrange this in one go and just get it sorted. However, if I'm not, and if I don't want to take risks, well, I might as well just do it properly, do it slowly, and I'm just going to evaluate the left-hand side first. So 26 squared minus 14 squared, I can just put that straight into my calculator, and that tells me that this side is 480 equals 2 times 0.35, so 2 times 0.35 is equal to 0.7. X is still x. Now, if I'm not that confident in rearranging, well, I've made it a lot easier for myself. So 480 stays where it is, divided by 0.7 equals x. I put that in my calculator, and again, I've got to make sure that I'm writing the full answer. So x equals 685.71 dot dot dot, and I'm getting that getting the answer right, and then I'm going to be rounding that to two significant figures. So because that's a number 5 here, that will change to a 9. So the distance that I'm going to get here is going to be 690. If you used a if you use the original acceleration rather than rounding the acceleration, you might get a slightly different answer. But again, like, it doesn't matter as long as you're clearly showing your work in, that the examiner can check. There's another way of doing the same question. So if you prefer the other way of doing it, then you can do. So I'm just going to rub this out, and we can have a look at the other way of doing it. That I know because they've given me a velocity time graph, I know that the area under the graph must be equal to the distance traveled. And again, from my content, that's just something that I need to know. So I'm going to show the examiner that I know that area under velocity time graph equals distance or displacement. So I've shown the examiner that I know this, and then I can either call this a trapezium and use the formula for a trapezium. So that would be a trapezium there. Or if I want to, which might be a little bit easier, I can just divide it into a triangle and a rectangle and then just break it down here. And if I wanted to do that, I could say area of triangle equals half times base times height, and then put those numbers in, equals, and I think this is 204. Area of rectangle equals base times height. Again, just put those numbers in, and it tells me that the answer is 476. Add those together, so the total area is going to be the total displacement. I'm showing the examiner exactly what I'm doing. 204 plus 476, and I think that gives a slightly different answer from the previous one. So that's going to give me 680, but like I said, that's because, so if you use this full value, you would have got 680. It would have rounded to 680. If you use the rounded value, you get 690. But as long as you're showing your working, that's all that matters for this. Okay, so part C for this question then. So this is an explain question. So the first thing that I need to do is just make sure that I'm going law, principle, formula if I can. Well, what's the key piece of information that they've been giving me here? So they're telling me something about force. They're saying that the force remains constant, and it's also saying what happens to the acceleration. So I'm going, is there a formula that's got force and acceleration in there? Yeah, there is. It's resultant force equals mass times acceleration. So I'm going to abbreviate that to F equals ma over here. Okay, now, what's the important piece of information that they've given me from here? They've said that the force remains constant. So why are they telling me that? That I'm suspicious, like, why would they give me our force is constant? Well, the reason is because they want me to do proportionality with this. So if force is constant, I should know from my proportionality that the mass is going to be inversely proportional to the acceleration. So now I've done the law, principle, formula, I've got that kind of thing right, I've given the relationship. The next thing that I'm going to do is to state the obvious. So it says the rocket is taking off. I know it must be something to do with mass, something to do with acceleration. Well, it can't be acceleration because that's what the final answer is going to be. So it must be something to do with the mass. What's the obvious thing that I can say about the mass when that rocket is taken off? Well, I know that the mass must decrease because the fuel is burning. So when the rocket's going off, obviously the fuel is burning. So I've now stated the obvious. And now I'm just going to link that back to I've used the keywords already, and I'm going to link that back to the relationship that I've just said. And I'm going to say, well, therefore, the acceleration must increase. And obviously I'm going to write the full words in the exam, but I'm just abbreviating it quickly here. Okay, so we've got a calculation question here again. I've seen the word calculate, so I know that I'm going to have to use a formula, and this time it's an unfamiliar calculation, so it's a formula that I've never used before, so that means that they have to give me the formula. So I've got the formula written right here, and this question is just about, am I able to sub in, am I able to rearrange, am I able to evaluate? So I'm going to check for conversions like I always have to. So it said meters, that's fine. Meters per second squared, yeah, everything's okay. I don't need to do any conversions here. And then, okay, so I'll write the formula, so just standard procedure for calculation questions. So I'll write the formula. What am I looking for? I'm looking for time. So I'm going to put time there, but obviously that's a squared, so I've got to keep it squared. That's something that a lot of students might make a mistake on, they'll forget that. So I've got to make sure that I'm being careful of that. Then 2 is 2. H, it tells me is 1.4, so I'm going to write 1.4. G, I should remember is 10, but it tells me anyway because I'm being nice, but still, I'm going to write 10 there. Now, if I'm more confident with rearranging and formulae, okay, I can just do this in one step. If I'm not, it's not going to hurt me just to take another step, just to do it a bit more slowly. So I go t squared, okay, 2 times 1.4 divided by 10. So then I know that is going to be 2.8 divided by 10, which is 0.28. Obviously, I've got to do all this on my calculator. So if t squared is 0.28, how am I going to get t? Well, I'll just take the square root of 0.28. And then, as always, I've got to make sure I'm writing the full number from my calculator. So that's going to be 0.52915. And then still, I'm going to, even though it doesn't say it in this question, I've got to make sure that I'm rounding to two significant figures. So 0.53 is going to be my answer. And then I'm pretty happy that, yeah, okay, I've got full marks over here. So part B to the question, obviously reading the question, what's they telling me? So I've got all the information that they're saying. It says suggest the reason for why the student's value is different from the calculated value. Well, this is something that I'm kind of looking for because it's always coming up as a very popular question that comes up. That if I'm ever asked about inaccuracy in time, I can see that they're using a stopwatch. I'm looking for a reason to say something about reaction time. So I know here that the reaction time of the students is going to be quite big. So there's always, when I'm using a stopwatch, I'm just going to use the key term there, reaction time. I can just say, oh, the student is large. And I can put compared to the time that it takes to fall or something like that. But as long as I'm using that key term as their reaction time, okay, I'll explain a little bit. But I'm pretty happy that I've got the mark just by saying that one now. Suggest one improvement so that their value for t is closer to the calculated value. Again, this is a question I'm looking for because whenever they're saying using a stopwatch, I already know the thing that I'm going to do to improve it. So I'm just going to make sure that I'm using light gates instead. So use light gates or a sensor, electronic timer. So light gates connected to electronic timer, something like that I'm saying. Another thing that sometimes you look for the opportunity to say when it's anything to do with time is about like taking a video of it and then slowing it down. But in this situation, I can see that light gates is the best one. So yeah, I'm pretty happy that I've got the mark for this one over here. Okay, so then the next one is a calculation question. So let's have a look at how I'm going to do the calculation question. So as always with all calculations, first thing is I'm looking at the units. So that's proper units, that's proper units. So I don't need to do any conversions. Now I can try to identify the formula that I've got to use over here. So what are the things, the first thing that's the most important? Well, I'm looking for the force. So I'm definitely going to need to tell me that I calculate the force as well. So I definitely need the formula of force. What have I got? I've got a momentum and I've got a time. So is there a formula that's got force and momentum and time in there? Yeah, there is. I know it's force equals change in momentum divided by time. Okay, so whenever I see something that's a change in, I always know it's final minus initial. Well, they're saying before it hits the floor it's 8.7, so I know that's its initial momentum. It hasn't given me a final momentum, but is there an indication in the question that I know what the final momentum is? Well, yeah, it's hit the floor, so again, they're secretly telling me that, yeah, the final momentum is going to be 0. So the change in momentum is always going to be final minus initial. So final momentum minus initial momentum divided by time. Okay, we've already said that the final momentum is going to be 0, so I know that's going to be 0 over here. The initial momentum, it tells me is 8.7, so I'm going to write down 8.7, and then the time it tells me is 0.35, and I'll put this in my calculator, and I'm going to obviously write the full number from my calculator. As always, I'll have to move it up here because there's not enough space. So that's going to be minus 24.8571, and then always round to two significant figures. I've got to get into the habit of doing that. So I know that the answer here is going to be minus 25 newtons. Now for this question, it doesn't really matter if you put the minus or not, because I'm choosing the direction that, because it says the momentum here is 8.7, I can choose that, okay, downwards is going to be positive or downwards is going to be negative. So if you don't put the minus in this question, it doesn't really matter as long as you've got all the other work in. Okay, now for the next part of the question, the magnitude and direction of the force exerted by the box on the floor. So I've got to, again, identify what is it that the examiner is trying to tell me here, or what, yeah, the information they're trying to tell me, and therefore what am I going to say to get the marks? Well, I can see that it's something to do with force. The question is about force. So and I can see the word direction in here as well. So whenever it's to do with forces, I know, okay, it's probably going to be something to do with one of Newton's laws. Well, here we've got um, indication so that it says floor on the box and then the box on the floor, and the fact that it says the word direction in there, this is all telling me, okay, yeah, this is going to be Newton's third law. So when there's any indication that there's a question about Newton's third law, I know that they're always going to be testing me on the same four things. So the four things that they're going to be testing me on is that there's different objects, the same size of force, same type of force, and opposite direction. So whenever I've identified as Newton's third law, I know it's got to be one of these four things, or two, three, whatever, however many of these things it's going to be, but it's got to be out of these things always. So I identify it as Newton's third law. It's always, I've got to make sure that I'm saying these to get the marks. Okay, so what is it asking me for here? There's 2 marks, so it's probably going to be 2 things. The first thing it's saying is the magnitude. Well, magnitude means size, so that's obviously this thing over here, same size. Well, if the first one was 25, the magnitude was 25, the next one's also going to be 25 newtons. And then the direction, well, which of these indicating direction? Well, it's this one over here, saying it's in the opposite direction. Well, if the box is hitting the floor is going to exert a force upwards on the box to make it stop. So that means that the direction of the force on the box and the force is going to be the opposite one, and therefore the direction's got to be down. And then again, I'm happy that I've got this mark for this question. Okay, so part D, the last part of this question, we've got another, I can see that it's a calculated mass of the ball. So another calculation question over here. Now this one, I can see it's got a 4-mark question. So always when there's a 4-mark question for a calculation, there's a couple of reasons why it might be a 4-mark question. The first reason is because they're asking you to do conversions and rounding. And the second reason is because I'll have to combine more than one formula. So it's always pretty much always going to be one of those 2 reasons. So let's just have a look at the units for this question. So there's units there, and they're correct units, and then units here are correct units, unit here is correct units. So everything I've been given in is correct units, so there's no conversions. It doesn't say anything about give it to this number of significant figures or anything like that. So probably I'm thinking, okay, because it's a 4-mark question, chances are there's 2 formulae I'm going to have to combine. So it makes it slightly harder, but as long as you just follow a standard sensible technique, then you're going to do pretty well in this. So let's have a look at what the normal thing is that we're doing. So I know that I'm going to calculate the mass of the ball. I don't know what the formula is for this yet, but I know it's got to have something to do with mass. So I'm going to write down M for mass. It's saying that's released from the clamp and falls 3.8 meters, so it's going to be 4, so I've got some kind of distance. So I'm going to write down X. It gives me the momentum, so I'm going to write down P. Again, it's been very nice to me by giving me the acceleration, even though it doesn't have to, because the fact, so in a real exam it might not say that, but here it's telling me that it falls. So the fact that it falls means that I should just know that it's 10. So straight away when I see the word falls, I'm going to put acceleration equals 10 over here while I've got the acceleration. So these are all the things that I've got. Now, is there anything else that I've got? Yeah, there is. I'm not going to say it just yet, but there's another indication in there that there's some kind of hidden information, and hopefully if you've done this question already, you've spotted it. But let's just have a look at how I should be doing this. So I'm pretty stuck on this because I can't see any, like I don't know there's any formula with M, X, P and A in there. I'm looking at the formula sheet, yeah, there's nothing in there that I can find. So I'm going to just use the technique that, okay, if I can't get it straight away, I'm just going to do something that I can, and at least I might get 2 marks for the question. And then hopefully once I do that part, well, I'm going to find out how to do, or give me a clue to do the rest of it. So let's see if there's any indication. Well, the fact that it's falling and it's accelerating, we know already from previous questions that if something is accelerating, I know that I'm going to be using one of those 2 formulas, v minus u over t, or v squared minus u squared equals 2ax. And I just need to see, have I been given a time, or have I been given a distance, or is the question about time or about distance? So it's accelerating, so I'm going to start with one of those because that's pretty sensible. And I'm looking for that. Does it say anything about time? I can't see anything about time. Does it say anything about distance? Oh yeah, I can see that this thing over here is in meters. So because there's something in meters, okay, I'm pretty happy. I might as well just start with this and just see what I can do. So I'm going to go v squared minus u squared equals 2ax. Unfortunately, it doesn't have the m that I'm looking for, but remember, I just know, okay, I'm doing something and then hopefully I can get an m later. So have I got any kind of v in there? Does it tell me the final velocity? So that's when the ball is here. No, it doesn't. So that's an unknown. I'm just going to write that down. So I can only have one unknown in the equation. So that means in order to use this, I must have a u squared or a 2 or and a 2ax. I've got to have all of them. So does it tell me the initial velocity in this question? It doesn't say anywhere that the initial velocity is this or that. I can't see it. However, this is this again the secret piece of information that's hidden in there. I can see it says it's released from the clamp and it falls. So if it's been released from the clamp, what do I know the initial velocity must be? Well, first it was stuck in the clamp, or the initial velocity must have been 0. So I'm going to write 0 in there, and I'm still going to put the square just to show the examiner that I know that there's a square there. Okay, so 2 just stays as 2. I know that a is going to be 10. And what is x? It tells me that x is 3.8. So I'm going to write x is 3.8 over here. Okay, so now I'm just going to do this in stages. I might not be confident with my calculation. So I'm going to say v squared is equal to 2 times 10 times 3.8. So I need to obviously get my calculator. And I'm going to say 2 times 10 times 3.8 is equal to 76. But remember, I'm showing that the examiner that I know that it's v squared over there. So I've got that 76 over here. And then obviously v is going to be the square root of 76. So therefore, v is going to be 8.718. And then I might as well round it to significant figures here. So okay, v is 8.7 meters per second. Now, I've not got an answer, but I've done something that I can do. And yeah, I might get some marks because I've shown my working very clearly. But now that I've got a new piece of information as v, I can put that over here because I figured out a v. So now let's just do the same thing again. I'm still looking for the mass of the ball. So I'm going to write down m for the mass of the ball. What haven't I used yet? Okay, so I've used the distance, so it's probably not going to be that. I haven't used p, so I'm going to write down p in there. I've used a, so it might not be that. Okay, v I've just got. I'm going to write down v over here. So is there a formula with m and p and v in there? Oh, actually, yeah, no, there is. It's momentum equals mass times velocity. So now what am I looking for? M, I'm going to write down the mass first. Have I got the momentum? Yeah, I have. It says 0.4. Have I got the velocity? Yeah, because I just worked it out. Multiplied by 8.7. And now I can just rearrange this happily. 0.4 divided by 8.7. I'm going to put that in my calculator and write the full answer. So 0.04598, and I'm going to round to two significant figures over here. So I know the mass of the ball is going to be 0.046. And again, so this was, if like I couldn't see what I was doing at the start of the question, but I just used a sensible technique. I didn't panic and just did, okay, I'm going to do what I can do. And then I just realized, okay, there's 4 marks. I might need to use 2 formulae in there. I've got something, and then that gave me a clue to the next thing. Okay, I'm pretty happy now. I've got full marks for this question. That a lot of students might just panic and miss it out and go, oh, I don't know how to do it. I'll come back to it later. And then they still can't figure it out. Okay, so the next question, I can see it's about astrophysics. And the first thing it says, okay, the asteroid belt is part of our solar system. So this is just content that I need to know. And it says Vesta is an asteroid and asteroid belt. Okay, so basically the question is asking me where's the asteroid belt, and I just need to make sure that I know my content. Basically, I've done my revision, and I know the asteroid belt is between Mars and Jupiter. So the answer's got to be C. Okay. Next one, calculation question. I'm still doing the exact same thing I do for all calculations. So that says meters per second. That says meters. I don't need to do any conversions. I'm fine. So now, how do I identify the formula? Well, I'm looking for time, so I need a formula time in there. It gives me a speed, and it says it travels a distance. Okay, so I should be able to realize what formula I'm going to be using here. So I'm going to be using speed equals distance over time. What am I looking for in this situation? I'm looking for t. So I'm going to put the t in there first, and now I can fill the other stuff in just to make sure the examiner knows I know this was v, I know this was d. So the v was 1.9 times 10 to the 4. The d, it says, is 2.2 times 10 to the 12. Okay, and now it's just about, can I rearrange this properly? So if I'm rearranging it, the t's on the bottom when it goes across the other side will be to the top, and the 1.9 will move to the bottom. So now I can rearrange it and say t equals 2.2 times 10 to the power of 12 divided by 1.9 times 10 to the power of 4. I'll put that in the calculator, and it's 1.1579 times 10 to the power of 8. And then I'll just make sure that I can round it to two significant figures. So that's going to be 1.2 times 10 to the power of 8. And I'll put that in the answer line, 1.2 times 10 to the power of 8. So just a pretty standard form in the question that we've got over there. Okay, explain why Vesta is accelerating even when it's traveling at a constant speed. So it's a 2-mark question over here, and it says constant speed accelerating. Again, this is just content that I need to make sure that I'm knowing. So what are keywords that I should be saying over here? What's the law, principle, or formula they're telling me here? And okay, so I know that this is through a scalar vector. So I know the keywords I'm going to be using are about scalar and vector over here. So it says a constant speed, but it's accelerating. So speed is a scalar, acceleration is a vector, or velocity is a vector. So if it's traveling in an orbit, I know that, well, the first thing that I'm going to say is either velocity or acceleration are vectors. Speed is scalar. I'm just going to use all the keywords that I can in there. And then, so that means that even though it's traveling at a constant speed, well, if it's a vector, it must be changing direction. Is it changing direction? Yeah, because it's moving in a circle. So I'm just going to say, well, Vesta is accelerating because it's changing direction. Okay, so I've identified the content pretty quickly, what the examiner wanted me to say, and I've just given those keywords. I've just said that pretty easily. Okay, now this is a question that comes up quite a lot, and it can come up in different topics. This time I've put it in astrophysics, but I'm saying something about the temperature. Why does it continue to rise even though it's absorbing energy from the sun? It's always the same answer for these questions. It's a 3-mark question in this situation, but a lot of the time it will come as a 4-mark question. And just what I need to know is that everything is continuously absorbing and everything is continuously emitting energy. So everything's absorbing energy, everything's emitting energy. So if something is heating up, it's going to be absorbing energy at a greater rate than it is emitting energy. If it's cooling down, it's going to be emitting energy at a greater rate than it's absorbing energy. If it says it does not continue to rise, even though it's absorbing energy from the sun, well, I know that it's definitely going to, because it's emitting energy at the same time, it's probably going to be staying at the same temperature. So I can say that it's told me in the question it's absorbing energy from the sun. So I've got to say that Vesta is also emitting energy. And then the word that I've got to use is that it's emitting it in the same rate. So I've said it's emitting energy. So now I'm going to say at the same rate that it is absorbing energy. And it might look like it's not, how can it be worth very many marks? But it's because the reason why they give you the marks here, so like I said, it could be worth 4 marks. I've said it's emitting energy, that's going to be 1 mark. I've said it's absorbing energy, that's going to be another mark. If I said the same amount of energy, that's the 3rd mark. But the fact that I've used the word rate in there, that's what gives me the 4 marks over here. In this case, yes, a 3-mark question, because they've already said it's absorbing energy, so I might need to say that. So I can't get a separate mark for saying it's absorbing it. But I'm always looking out for this question. If it says something about increasing energy, increasing temperature, decreasing temperature, or staying at the same temperature, this is the way that you've got to phrase it, and just make sure that you're using that keyword rate. Okay, so part E to this question, we have got a calculation question over here, and it's given me the formula over here. Well, the first thing, even before I'm doing a calculation, is saying give me the unit of K. Well, if I want a unit for something, we've done this before with the graph questions, I've just got have a formula that says that equals, and just see what's on the other side. So if intensity equals K over D squared, I know that K is going to be equal to intensity times d squared, and now I've just got to put the units in here. Now, especially when you're doing A level, you would put the units in square brackets, but you can, like, there's no harm in doing it here as well. So what is the unit for intensity? Has it told me? Yeah, it has. The unit for intensity there is watts per meter squared. So I'm going to write here watts per meter squared. Have I got a unit for distance? Well, yeah, I have, because I know that distance is normally measured in meters. Here it tells me that it's in AU, so I could use AU as well. But in order to make things cancel nicely, I can just use meter squared as well. So either, and I'll do it both ways, to be fair. But I'll just do it the simple way first. So the unit for distance is meter, but it says distance squared, so I've got to put meter squared. And now I've just got to simplify this. So it might be easier to simplify it if I write it as a fraction like that. So W over m squared multiplied by m squared, and that's same as m squared over 1. So these cancel. So my answer is just going to be watts over here. So I know that, yeah, I'm pretty happy that my answer is going to be watts. Now, if you didn't write m squared and you wanted to write in there AU instead, because you couldn't remember that distance is measured in meters, I could do the same thing, and this would also be legitimate. So instead of the meters, I put AU, because that's the one that it told me, squared. I'm just doing the same thing. So watts divided by meter squared multiplied by AU squared. So that is just going to be watts AU squared per meter squared. And this can also give me the answer if I wanted to do it that way. Calculate the intensity of the radiation from the sun at Vesta. So now I've got the obviously the unfamiliar equation over here, and there's a couple of ways that you can do this, but the easiest way, if you're not that confident with doing calculations, is just work out the K first that you've got. So because it's a constant, I know it's just going to stay the same. So let's have a look at it. Obviously I'm going to write the formula first. So intensity equals K over D squared. Have I got information about this thing over here? So it's giving me that the distance between Vesta and the sun is 2.4 AU. 1 AU is between the Earth and the sun, so I've got two different distances. The intensity of the sun's radiation reaching the Earth is this one over here, 1,400. And then I need to find out what's the intensity of the sun's radiation at, what does it say here? The intensity of radiation at Vesta. Okay, so this, I've only got one piece of information that's about intensity of the sun's radiation reaching the Earth. So that's obviously the one that I'm going to have to put in intensity. So I'm trying to work out K, so I'll put that first. The only intensity that I've got is 1,400. So I've got to write down 1,400. But because I've got two Ds over here, I've got a 2.4 and I've got a 1, I need to know which one actually matters. So over here, it's saying intensity reaching the Earth. So then which of these distances to do with the Earth, is it 2.4 or is it 1? Well, it's going to be 1. So that is going to be my answer there. And therefore I know that K is got to be equal to 1,400. Also 1 squared is just 1 as well. So K is going to be equal to 1,400. So now I've got my answer for K, and if I want it, I might as well put the unit as well. So now, because it's a constant, now I can just put that constant back into the equation. So I'm going to say intensity equals, instead of saying K, I know K is equal to 1,400 divided by D squared. Now it says calculate the intensity of the radiation from the sun at Vesta. So I'm looking for intensity. I'm going to write intensity first. Intensity 1,400 divided by, what's the new distance? Well, it tells me here that the Vesta one is 2.4 AU, so I'm going to put 2.4. I've always got to make sure I'm remembering to square it, so I've put the square there. Now look how I'm making sure I'm showing my working properly, because if by the time I've done all that, I might forget to square it because I'm so excited that I've got on to the next part of it. Well, showing my working very clearly, at least I can get method marks for it. So now I'm just going to put this into my calculator and see what the answer is that it's saying. So 1,400 divided by 2.4 squared, and that's going to give me 243.05. Write the full number and always round to two significant figures. So now I'm going to say 240 is the answer, and it's giving me the units there. So now again, I'm pretty happy that I've got that one right. So for this question over here, I can identify the topic is radioactivity, and let's have a look at what the keyword that stands out to me is. So the fact that it's saying food can become contaminated. Basically, the examiner's testing me, do I know the difference between contaminated and irradiated? So if something's contaminated, I know that the actual substance is on there. So in this case, it's food, so I know the actual substance is inside the food if it's been contaminated with that. So the first thing that I'm going to do is just make sure that the examiner knows I know the definition of this keyword they put in there. So they put a keyword, I know the definition of it. So if it's contaminated, I'm just going to say that means contaminated means the substance, the radioactive material is on or inside the food. So I'm just going to say that inside the food. And now I've just got to link this to the question. So why does this matter? Well, what are the other things that I know from this topic about radioactivity? Well, what's a keyword I can use? It's going to cause ionization. So if it gets inside your body, it can cause ionization inside your body, or ionization of the cells inside your body, or damage the cells inside your body. And I'm pretty happy that this is going to be worth the 2 marks now. Sometimes people add there's some of the danger that can have. So it can cause mutations or cause cancers. So I might as well put that on there because I'm just playing it safe and make sure that I'm definitely getting every mark from there. So cause mutation, cause cancers. And now I'm happy that I've used the keywords. I've shown the examiner I know what's meant by the key thing in the question, and I've linked it to what I should be linking it to. Now for this next part of the question, I'm going to take a pretty similar approach. That what's the key word that stands out to me, the key piece of information? Well, they're saying this one's irradiated. So again, I've just got to show the examiner that I know what is meant by this term irradiated. What's the difference between irradiated and contaminated? So we said contaminated is when the actual substance is inside the food, but irradiated is when the substance is exposed to the radiation or the radioactive source. So here it was inside it. Before irradiation, the food here is just exposed to the radioactive source. So now I've got to say, what's the point of me exposing the food to the radioactive source? And it's to kill bacteria. So this is just something that I should know from my content revision. Oops, bacteria. And so it's going to be killing the bacteria. Okay, why do I want to do that? Okay, sterilizing it, or I want to make it last longer, preserve it. So just any of those things. Sterilize it, preserve it. And any of those things are pretty reasonable now for me to get a mark for this question. Okay, so part C then, what's the kind of stuff that stands out to me? So they're testing me specifically about gamma radiation, and it's giving me a lot of information here that when it emits the gamma ray, the number of protons don't change, the number of neutrons don't change. So even if I can't remember it from my revision, I should be able to work it out from here. So if the protons don't change and neutrons don't change, well, it's obviously not emitting anything. It's not emitting any particles from there, but obviously it says it does change. So what's the only thing that's left over that it can be? Well, if I can't remember what it is, I'm just going to show the examiner, okay, what do I know about gamma radiation? Or hopefully I can remember that that's energy, it's just pure energy. So if it's saying it emits the gamma ray, well, it must be something to do with energy. It emits it, it must be giving it out. So it's giving out energy or it's losing energy. So even if I couldn't remember from my content revision, just from the information that's given to me in my question, I'm just saying something sensible from there. Okay, what's the point of it losing energy? Okay, I can say it becomes more stable. So I already think I've got the mark for the first bullet point anyway, but it never hurts just to say anything else that I know about it. Okay, it becomes more stable. I can say about the particles in the nucleus being rearranged. All of that's pretty sensible stuff for me to say. So 6-mark question now is the last part of this question. And I know that as long as I apply the technique for 6-mark questions, for any 6-mark question that comes up, that's what's going to help me get into the higher band of marks, which is obviously what I'm aiming for. Even if I don't know very much about the topic, I've always got to apply the same technique for 6-mark questions. So what do I have to do? Well, the first thing that I need to do is make sure that I'm breaking it down. So breaking it down into 2 or 3 parts at least, or however many it seems sensible, but it's normally 2 to 3 parts. I've got to decide what I'm doing when I've seen the question. After I've done that, I've got to make sure that I'm saying something about each part. So we know that for the content stuff, okay, there must be some law, principle, formula, or something, the state, the obvious thing that I'm saying about each of those things. I've got to make sure that I'm always using the keywords and make sure that I'm linking it back to the question for each of those. So I can see that's a 6 mark question. So obviously I've got to try to see first how am I going to structure it, what parts am I going to break it into. So gamma radiation is produced by radioactive decay. Then it says alpha and beta are produced by radioactive decay. Okay, now it gets the actual question. Compare the processes of alpha decay and beta decay. And this is actually a really nice question because it says your answer should include what each radiation is and what effect each decay has on the original nucleus. So they've basically done half the job for me. They've told me how I've got to break it down. So I know that you could say it's going to be 2 parts. Yeah, half it's going to be alpha, half it's going to be beta. But I've got to say what alpha is. I've got to say what beta is. I've got to say how alpha affects the nucleus. I've got to say how beta affects the nucleus. So now I know that I've done this, I can rub that thing out of the way. And let's just have a look at what the things I'm going to say for it. Hold on, let me just get that rubber. Okay, so I've broken it down into all those parts. Now let's see, I'm just going to go in order because that's the most sensible way to do it. So the first thing that I realized from my annotations here is I've got to say what alpha is. So I know that alpha is 2 protons and 2 neutrons. Obviously you'll write it out in full in the exam, but I'm not going to do that. I'm just going to do it quickly. So 2 protons and 2 neutrons. I know that's the same thing as a helium nucleus. And again, you'll write it out properly in the exam, but I'm just going to do it quickly here for the sake of it. Okay, well, if it's got 2 protons and 2 neutrons, what more can I say about that? Well, 2 protons, so it must have a charge of +2. It must have a mass of 4. And now I'm pretty sure that I've said enough things about the what an alpha particle is. Okay, so now let's say what a beta particle is. So beta particle is electron, or beta minus. So when you say beta without qualification, it means beta minus. So it's going to be an electron. So the fact that I know it's an electron, what can I say about that? Well, the charge must be -1. What's going to be the mass of it? I can say it's going to be close to 0. Or you could say, if you want to say 1/2000, or people give that as a fraction, so 0.005, whatever. So I've given the charge, I've given the mass. So I'm happy now, I've covered what each type of radiation is. So if I'd just done this, I would have been in 1 to 2 marks. Because I've done this, I'm pretty confident that I'm into the 3 to 4 mark band. And now, as long as I say what each decay has on the original nucleus, well, I'm probably going to get 6 marks for this now. So what is it? So if an alpha is going to leave a nucleus, well, because it's got 2 protons and 2 neutrons, it's going to leave a nucleus. So alpha leaving a nucleus, well, what must it mean to the mass? It means the mass of the nucleus must be decreasing by 4. And it must mean the charge decreases by 2. So that's pretty simple. It's pretty obvious from the thing that we said earlier. But even though it's obvious, I've still got to say it because the question's asking me to say it. I'm going to get marks for it. So that's what I'm just going to make sure that I'm going to give the examiner every opportunity to give me those marks. Now, when a beta leaves a nucleus, this is a bit more complicated because, well, it said a beta particle is an electron. So how can an electron leave the nucleus? Well, the only place where I can get an electron to leave the nucleus, and I'll draw a little diagram here, obviously you're not going to do that in the exam, it's just to help you understand it, that I can imagine that the nucleus has got protons and neutrons. Well, the proton's got positive charge. And then if a neutron's neutral, one way that you can think about it is, okay, it must be made up of positive and negative charge. It's not strictly true, but for GCSE, it's the easiest way to think about it, to remember what's going on. Well, if an electron is going to leave the nucleus, where's it going to come from? The only place it can come from is here, from the neutron. So if this electron is leaving as the beta particle, well, what's essentially happened inside the nucleus? Now I can put this as a sentence. So for the beta decay, what happened? Well, whoops, decay. That neutron is now positive charge, so it must have changed into a proton. So I've shown the examiner that I know what's going on over there. Now, what can I say about the mass and the charges here? Well, if a neutron changes into a proton, the mass is going to be the same. So I'm just going to say the mass stays the same. Because they both weigh 1, they've both got a mass of 1. So that's fine. But then if a neutron changes into a proton, well, then that obviously means that I'm going to have 1 extra proton. So proton number must increase by 1. Now, I'm pretty happy that this is 6 marks here. But again, just to play it safe, because I know in both of those situations, the number of protons have changed, I might as well say both alpha and beta means there's a new element that's been formed. Whereas if gamma is just giving out energy, this isn't in this question, but it might be in a question in the real exam, the element's going to stay the same. It's just going to reduce in energy. So obviously that's not this one, so I'm not going to write it down, but that's the kind of thing that you're going to be looking out for in the exam. Make sure you know the difference between alpha, beta, gamma decay, what they all are, and the effect they're going to have on the nucleus. Now for this question, some students start talking about, oh, alpha's got this ionization capability, penetration capability. Yeah, fair enough if you need to say something if you can't think of any of this, but by breaking down this question properly, I've made sure that I've just specifically said what the examiner wants me to say. All the other stuff about ionization, penetration, anything like that isn't going to get me any marks for this particular question. But obviously in a real exam, you don't know what they're going to ask, so you do need to still know about the penetration, ionization, all of that, of alpha, beta and gamma, and the range in air, what's it stopped by, all of that kind of stuff that you've covered in the lesson and your revision. So nice recall question here. Yeah, so it's just saying renewable source of energy. The only thing I need to be careful about here is the fact that it says other. So it's giving me the example of wind as a renewable source, 2 other renewable sources of energy. I can just recall any of them from my revision. So I can say anything about like hydroelectric or tidal, geothermal, biomass. I can choose any of those, solar. It doesn't matter which ones I'm saying, any of those things will be fine. So next part of it, what's the command word in this question? I can see that it's calculate. So obviously I'm going to need some kind of formula in here. Well, in this one, because it says calculate the efficiency, there's only one formula that it can be. So the first thing that I'm going to be doing is checking for conversions as always. So it says kilojoules here and it says kilojoules over here as well. We'll go through like a couple of ways that you can do it, but let's just do the standard way first. So I've realized that there's conversions in there, so I'm going to say, okay, 6.2 times 10 to the 3 and 2.2 times 10 to the 3. I'll write that down now to make sure I don't forget it afterwards. There's only one formula that's got efficiency in there, so percentage efficiency is equal to useful over total times 100. Now I'm just going to put the numbers in here. So what's the useful energy? It says, because it's saying input and output, oh, I don't know which one's which. Well, I know that the one that's coming out to the national grid, that one's going to be useful. So I'm going to say here, that's going to be 2.2 times 10 to the 3. The total energy must have been the energy that was going in. So that was 6.2 times 10 to the power of 3. And then I've said multiplied by 100% over here. I said percent there. Okay, now if I didn't know which one was which, well, how should I know anyway? Because the input, the total energy has always got to be bigger than the output. So even if I wasn't sure, okay, which one's referring to useful, which one's referring to total, it's always got to be the smaller number is going to be the useful one and the bigger number is going to be the total. And then, yeah, there might be some questions where there's like wasted in there that I've got to be careful about. I think how am I going to get the total if there's useful and wasted? Well, I'll have to add them together to get the total. But for this one, it's just, yeah, it's a little bit simpler. And when I said there's 2 ways to do it, some of you might have realised this already. I know from here, even before putting it in my calculator, that times 10 to the 3 is going to cancel with that times 10 to the 3. So in this situation, in this question, I didn't need to do the conversions. So, however, I'm always just still going to do them. Even if I know they're going to cancel, I might as well still just do them, because some students will make the mistake of thinking, oh yeah, this is one where I don't need to convert, or this is one where I do need to convert. If you're thinking about that, then there's a chance that you might get it wrong. If you just always convert, well then if they're going to cancel, they're going to cancel, it's fine. So then you're not going to really lose anything by just doing the conversion. Okay, now then obviously I'm going to put this in my calculator. Always write the full answer, so that is going to be 35.48 blah blah blah, and then always round two significant figures, so this is going to be 35%. Another thing that you might have done is, if you didn't do percentage efficiency and you just said efficiency is useful over total, you don't have to multiply by the 100%, and then instead of 35% you would say 0.35. In this situation, because it doesn't say one or the other, you can choose which one you're going to give as long as your working is very clear. Just look out for it in the real exam. That it might say what is the percentage efficiency, in which case you have to give the percentage. If it says what is the fraction efficiency, I've not really seen that very often, but then it would be that one. Okay, so suggest a reason why it's impossible for the turbine to use all the kinetic energy of the wind. I already know that when there's questions on energy, there's something that I'm always looking out for. So there's always like a little 1 mark question, or very often there's a little 1 mark question at the end that's going to say something about this. It's essentially making me realise some energy is going to be wasted. And it's always got to be the same things that I'm going to be writing down. So if it says why isn't it using all of them, or why is the total less, or something like that, I'm looking for an excuse to basically give this answer. So some energy is wasted as thermal, due to friction. And then I've got to say friction where, and in this case I'll be friction of the blades, or friction within the turbine or the generator, or something like that. So friction in the turbine. So where the blades are spinning the thing around, yeah, there's going to be friction in there. Yeah, I'm just looking for an excuse to, sort of somewhere to put this as the answer. And I don't know which ones of these are going to give me the mark, or whether this one is combined with this one or something like that, or this one's combined with the other one. So I'm just going to say all of them. Obviously, in the real exam, you don't have to write the bullet points, just write as one sentence. But I've just written out bullet points to break it down. As long as you're saying all of those, yeah, you're fine. So for a 6-mark question, the first thing that I'm going to make sure I'm doing is I've just got to make sure I've got the structure right. So I know when a 6-mark question comes in the real exam, I'm always going to try to break it down into the number of significant parts that it needs to be in there. So however many parts there are there, 2, 3, there's going to be a minimum of 2, but there might be more than that, significant parts. Then for each part, I'm going to give some kind of law, principle, or formula. I show the examiner that I know what is meant by that particular thing that I'm saying. State the obvious, what's the key piece of information, or is there any key piece of information the examiner is trying to say to me that I can just say and get the mark for it. I'm going to double check that I'm using keywords in all of my sections, and then just try to make sure that I'm linking it back to the question as well. So let's have a look at how many parts there are in this question. So obviously reading the question, so it's talking about fission and fusion, the non-renewable source of energy. And it's telling me compare fission and fusion as possible sources of energy. And then it's nice enough to give me these 2 bullet points. So it might look like, oh yeah, there's 2 parts I'm going to break it down into, but let's have a look at these bullet points sensibly and see how am I going to make sure that I've definitely done everything that I need to do. So in the differences part, well, it's saying about fission and fusion. Whenever I'm seeing anything, any question at all, it doesn't have to be a 6-mark question, any question that says about differences, well, if I just define this and define that, showing the examiner I know what is meant by both of them, that's going to be my starting point. And then, yeah, if I want to make it clear that this is different because that, then yeah, fair enough. But my starting point is always going to be just define both of them. Once I've done that, I'm going to move on to the second bullet point. It says the advantages and difficulties in using these sources. Well, obviously that looks like it might be 2 parts, but then really advantages, I've got to talk about fission and fusion, and then difficulties, I've also got to talk about fission and fusion. So really there's 6 parts here that I'm talking about. So when I'm doing this question, I'm pretty happy that if I say something for each of those things, I'm definitely going to get 6 marks for this question, because there's a lot of parts I can break this one down into. So this is a very nice situation for me. So let's rub this out and then get started on the actual question. So the first thing, let's just go on the first bullet point, and it says fission first. So let's just get that out of the way. So what do I know is meant by fission? So fission is always when a large nucleus becomes unstable by absorbing a slow-moving neutron. So all I'm doing is just describing the process of fission here, and I've just got this from my content revision, but it was absorbing a slow-moving neutron, and then splits to release energy and further neutrons. That can go on to produce further fission or go to have a chain reaction. And I might as well just say both, because I want to try to get the keyword chain reaction in there, just again, to show the examiner I know the keywords basically. I've got an excuse to do that. Further fission in a chain reaction. So if I'm reading this, I'm pretty happy that I've used keywords in there. I've given the law principle formula, as in like I've given the basic principle of fission. I've given some obvious things, things that's happening. I'm using the keyword slow-moving neutron. I'm making sure that I mentioned about energy, releasing further neutrons. I've got chain reaction in there. I'm pretty happy that I have got this perfect. The only thing I can say, when I say it splits, I could say into smaller nuclei as well. Even though it's kind of implied, I want to make it very obvious that I'm saying everything right. Okay, so now if I'm talking about, still just going in order, well, the next thing was fusion, so now I'm just going to define fusion. So fusion is when two small nuclei, or two or more small nuclei, join, and they're also going to release energy. Okay, now, can I give any more detail about this? Probably I can say about, okay, they're going to need high temperature, high pressure, all of that kind of stuff. I can say what the small nuclei are going to be and what they're going to turn into. So I can say it's going to be hydrogen into helium. And I won't write it out in full because it's going to take ages, but obviously in the exam you're going to write it out in full. And the other stuff that I mentioned, I'm not going to say just yet because I'm already aware that it's going to come into the next bullet point that we're doing now. So if I'm talking about advantages of both of them, well, let's start with the advantages of fission. What's the advantages of fission? I know that it releases a lot of energy. And in the real exam, I'm showing that all of this is to do with fission, but I'm just trying to do it a little bit more quickly to get through it. So we know that fission is going to be releasing a lot of energy. What's another advantage? There's no greenhouse gases. And all of the content stuff that I know about from there, that's basically fine. What are the disadvantages of it? And again, I want to make it clear to the examiner that I am breaking this down properly. So fission disadvantages, what are they going to be? Okay, the radioactive waste needs to be disposed of safely. So you would write that disposed of safely. It could be hard to dispose of, risks of accident, all of that kind of stuff. And again, I'm not going to write it to save time, but that's the kind of stuff that you should be getting in there. Okay, so now I've done the advantages and disadvantages of fission. The last thing is going to be the advantages and disadvantages of fusion. Well, the advantages of fusion, again, it's going to release a lot of energy. So I'll just abbreviate that to energy there. Release a lot of energy. It releases even more than fission. There's just loads and loads of energy that it's going to release. There's not only are there no greenhouse gases, but there's actually no radioactive waste at all. So then what are the disadvantages? This was kind of what I was mentioning earlier, that you need very, very high temperatures, very, very high pressures. And because you need such high temperatures and pressures, it's pretty difficult to do that on Earth. So it'll happen in the sun very easily where there's high temperatures and pressures, but on Earth, it takes a lot of energy to get those high temperatures and high pressures. And because it takes so much energy, it's not really achievable yet you can't really get much energy from it or any energy left over, because the amount of energy that you're putting in, even as releasing so much energy itself, the amount of energy you're putting in is so much as well that you don't actually get any left over to use. So we can't really do it yet. But once it becomes more efficient, then yeah, fusion is going to be the absolutely perfect way of generating energy. Okay, so this is the end of the paper now. So going through that paper, that is, like, I've definitely got 100 marks for that paper. Because I have looked at the exam technique, I've made sure that I'm using all the correct procedures to get it right. And that's the kind of thing that you need to make sure that you're practicing by yourself when you're doing the next papers by yourself. Just look at how identifying what each question is, break down that question into how does the examiner want me to answer this. And then obviously you just need to make sure that you know the content. If you don't know the content, then even if you know how to break it down, well, there's nothing that you can say for it. So, okay, yeah, I'll post another video like for the next paper, for a different paper, pretty soon.